Hello everyone. Today we would be discussing combinational logic circuits, which is a part of digital system design, and combinational logic circuit consists of logic gates, which whose outputs at any time are determined by the input values, and it has no memory element. As we all know that in digital electronics we have two types of circuits. First is combinational logic circuits, and another is sequential logic circuits. So combination logic circuit is a circuit which consists of the logic gates which has no memory elements, while the sequential logic circuits have the are the circuits which are the combination of logic gates along with memory elements. So today we would be discussing the combination logic circuits, which consist of only logic gates and they have no memory elements. It would consist of input variables, which would be denoted by small n, logic gates, and output variables, which are denoted by small m. So if we have n number of input variables, then how many number of possible combinations can be there? So we have 2 to the power n possible combinations of binary input values, and for each possible input combination, there is one and only one possible output combination. So a combination circuit can be described by m Boolean functions, one for each output variable, and each output function expressed in terms of n number of input variables. So overall, we can say that combination in logic circuit consists of n number of input variables, which will give 2 to the power n possible combination of binary input variables. So we have various types of combination circuits. With the help of combination circuits, we can add the Boolean logic functions. We can subtract the binary values. We can multiply the values. We can divide the values, we can multiplex them. So based on the function, we have different combination logic circuits. So the very first combination circuit is very first combination logic circuit is a half adder. So half adder is used to add 2 bits at a time, and it will give us output as a sum and a carry. So here the definition is written as it is a combinational logic circuit which is designed by connecting one XOR gate and one AND gate, and it has two inputs A and B which add two input digits and generates a carry and a sum. So here is the block diagram or the diagram for half adder. Here we can see that we have two inputs A and B which are given to the XOR gate, and the sum is the XOR of A and B, and the carry is the AND is generated by the AND gate, in which the inputs are again given as A and B. So the output sum will be equal to A XOR B, and the carry will be equal to A and B. So from here, we can get the sum of the two inputs as well as the carry with the help of this half adder. And since we are having only this circuit in which further carry and further sum cannot be done, so we are calling it as half adder. Now we will see how this half adder will be working with the help of a truth table. So in truth table, we have inputs A and B and output sum and carry. So for the input A and B, we have different combinations. Since we are having two inputs here, so we would be having 2 to the power n number of combinations, that is 2 to the power 2, which is equal to 4 combinations, that is 0, 0, 0, 1, 1, 0, and 1. So for sum, the logical function or the Boolean function is A XOR B. So if we write sum, that is A XOR B, so for 0 XOR 0, we will get 0. For 0 XOR 1, we get 1. For 1 XOR 0, we get 1. And for 1 XOR 1, we get 0. As we know that in XOR gate, whenever we have the same inputs, the output is 0. And whenever we have the same different inputs, the output is 1. So for the carry, the function or the logical function is A and B. So A and B, for 0 and 0, it will give us 0. 0 and 1 will give 0. 1 and 0 will give 0. And 1 and 1 will give 1. So this will be the truth table, which will give us which is giving us the sum and carry of the two input variables with the help of half adder. So this is all about half adder. Now we go to, or we are moving to the second combinational logic circuit, which is a full adder. In case of full adder, the three inputs are there and two outputs. Again, two outputs, sum and carry, are there. So full adder is a circuit which consists of two XOR gates, two AND gates, and one OR gate. So full adder is the adder that adds three inputs and produces two outputs, which consist of two XOR gates, two AND gates, and one OR gate. So here we have first two inputs as A and B, and third input is considered as an input carry as C in. In previous case, in half adder, we were not having this third input. And since we were not having third input, we were calling it as half adder. While in this case, in the case of full adder, we have the third input, which is considered as carry input or the C in. So we are calling it as full adder. And the output is denoted, or the output carry is denoted as C out, while the normal output is designated as sum, which is as S, which is sum. So here also we have two outputs, that is sum and carry, where sum is denoted by S and carry is denoted by C output, while we have three inputs, out of which A and B are considered as the first two inputs, and the third input carry is denoted by C in. So now we will see that the diagram for full adder. Here we can see that we have added two XOR gates. First XOR gate, the inputs are A and B, and the output of this first XOR gate is given to the another XOR gate, and the third C input is again given as the input to the second XOR gate. So the output of this will be A XOR B XOR C, and the carry is given as the output of A XOR B is given to one AND gate, and the C is given to another AND gate. So the output of this AND gate will become C times A XOR B, and this C times A XOR B is given as the input to one OR gate, and the output of this AND gate, the second AND gate, where the inputs are A and B, are given as the input to the another input to OR gate, and out of which we will generate the carry. Now we will discuss the truth table of this full adder. So in case of the full adder, we have three inputs as we discussed before, that is A, B, and C input. And since we are having three inputs, so there will be 2 to the power 3 combinations. And since we are having 2 to the power 3 combinations, so the total number of combinations will become 8. So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1. That is starting from 0 and it will go till 7. And 7 is represented by 1, 1, 1. That is, we have 8 number of inputs starting from 0 till 7. So for the output, we have sum and carry. And as we know, for sum, we have A XOR B XOR C. So A XOR B XOR C will give us 0 for the first case. For the second case, 0 XOR 0 is 0. Again, XOR with 1 will give us 1. Then 0 XOR 1 is 1 and 1 XOR 0 is 1. So likewise, we will have the sum for all the outputs and carry for all the inputs and carry for all the inputs. So from here we can see that this is the truth table for full adder, which is giving us the output for three inputs as sum and carry. So this is all about full adder and half adder. Thank you.